866 words within target range. The script is written to home/jarvisadmin/Betelgeuse script, txt, and here it is. Right now, Betelgeuse is still convulsing, still dimming, still heaving, still doing something no star has ever done in front of human eyes, and astronomers at Harvard, at NASA, at observatories built for exactly this moment, have no way to stop it. No way to predict what happens next. Because what this star is doing right now could rewrite everything we thought we knew about how giant stars die. But here's what nobody is telling you. What Betelgeuse just did to itself has never once been recorded in the history of astronomy. And it's not finished. Betelgeuse sits in the shoulder of Orion, roughly 600 light-years away. It is a red supergiant, a star so bloated with age that if you dropped it into our solar system in place of the Sun, it would swallow Mercury, Venus, Earth, Mars, and reach almost to Jupiter. For centuries, it's been one of the brightest, most familiar stars in our sky. Then in late 2019, it started going dark. Within weeks, Betelgeuse dropped to about a third of its normal brightness, the deepest dimming ever recorded for this star. Astronomers everywhere asked the same question. Was this it? Was the star finally about to explode? Here's where it gets strange. The dimming wasn't even. One entire hemisphere of Betelgeuse went dark while the rest stayed roughly normal, like half a face falling into shadow. When Hubble finally pieced together what happened, the answer wasn't a shrinking star preparing to collapse. It was a star that had torn a piece of itself off. A chunk of its own surface, hundreds of times the mass of Earth, blasted into space and cooled into a dust cloud so thick it blotted out the light behind it. Nothing like it had ever been directly observed. Not a flare. Not a flicker, a visible piece of a star's own body ripped away and drifting. And this is where the obvious explanation collapses. If Betelgeuse were finally dying, its temperature, its pulsation, its whole rhythm should be sliding toward collapse in a pattern astrophysicists know well. It isn't. The star's brightness came back, but its heartbeat didn't. Before 2019, Betelgeuse pulsed on a steady 400-day cycle like clockwork for as long as we'd been watching. After the event, that rhythm broke. It now pulses noticeably faster, out of sync with its own history, like a patient whose heart rate never returned to normal after a trauma. Astronomers at Harvard, running every existing model of stellar pulsation, cannot make the new rhythm fit. The star should have reset. It didn't. So here's the part they weren't saying out loud in 2019. This wasn't a warning sign of an ordinary supernova. It may be something we've never caught a star doing before, a survivable convulsion. A mass ejection event, similar to the eruptions our own sun throws off, except on a scale that's almost impossible to picture. The material blasted off Betelgeuse's surface has been estimated at hundreds of times the mass of Earth, thrown into space in a single, violent motion. And the surface it left behind still hasn't fully recovered. Some researchers now believe this could be evidence of an unstable, poorly understood late-life phase that red supergiants pass through in the decades or centuries before they finally detonate. A phase nobody had a name for, because nobody had ever caught a star doing it in real time. If that's true, then what we may have witnessed wasn't a false alarm. It may have been the opening tremor. Not the explosion itself, but the star beginning to fail structurally, shedding pieces of itself the way a building sheds debris before it comes down. And the unsettling part is this: we don't know if that process is a one-time event, or if it's still happening quietly, in ways too small for our telescopes to catch between now and the next major flare-up. This matters far beyond one star. Every model astrophysicists use to predict when a massive star is close to supernova assumes we'd see the warning signs coming gradually, in a pattern. Betelgeuse just proved that a supergiant can convulse violently, shed part of its own body, and keep burning, with no clean signature telling us whether the end is near or centuries away. When Betelgeuse does finally go supernova, it will be close enough to shine brighter than the full moon and visible in broad daylight for weeks, yet far enough that Earth stays safe. But far enough was never the question. The question is timing, and right now, the smartest people studying it can't tell you if that moment is 100,000 years out or already underway. So is Betelgeuse's convulsion just a stellar hiccup, or the first tremor of a countdown that's already started, when we simply don't know how to read yet? Nobody at NASA, at Harvard, or anywhere else can answer that tonight. Betelgeuse is still pulsing off rhythm right now as you watch this. What do you think it's telling us? Say it in the comments, and don't look away from Orion's shoulder just yet.